Hi, my name is Ron Brash, and I'm the Director of Cybersecurity Insights at Verve Industrial Protection. This presentation is about ICS Advisories. So really, when you're an asset owner, do you want to sweat it? Do you want to worry about it or forget it? This is an insider's guide to navigating ICS Advisories, and there's plenty of pitfalls here, but there's a lot that most asset owners probably could learn from. So I don't get into the IT versus OT debates. I think it's fairly clear at this point in time. There's lots of material out there for 101 level understandings. But OT is a different beast. So I do need to summarize this up. OT is really about keeping the lights on and the water flowing or oil coming out of the ground, whatever have you, right? It's about managing risk, and managing risk is critical to the safety and the security of these processes and these industries. Without it, we probably wouldn't have most of the things that we enjoy on a daily basis. And organizations must really know their assets. They have to be able to understand what's relevant, be able to prioritize vulnerabilities, and also the remediation managing of the risk, right? You would do the same for your vehicle on the streets. The same would apply for your home. So do the same for critical infrastructure. But interestingly enough, after all of our experiences in industry and over a decade of experience, what you'll find is if you have a large asset inventory for even a discrete manufacturing facility, 70% of the assets, if not more, are often non-Windows. So what that means is there's a humongous domain for managing embedded vulnerabilities, but those are generally the harder ones to deal with because what do? On average, the Linux kernel or even a VxWorks kernel is 8 to 10 years old, and they're still being produced. They're still not products are not end of life. So you can kind of think about the overall scope of this. If there's no updates, no firmware, what do I prioritize? What do I need to know? And you need to think about things in a slightly different way. You just need to assume a certain posture. And if you look at overall in OT, there's over 450 different network protocols, and yet they're 99.9% of them are insecure, right? OPC UA and some of the newer ones I'm excluding from this, but if you go back in time, there's many different other protocols out there. And all of those will have their own idiosyncrasies because they were built for a different purpose and likely not including security or adequate testing. So what is a vulnerability? And I think that's a very critical thing to discuss because there's many different definitions of it. There's the electronic versions of it, there's the cyber versions of it, there's the engineering definitions of it. But really what a layperson needs to know is it's a flaw. It's a poor design choice or an incomplete configuration of a product or software that leads to negative conditions. When you take into that consideration, you can kind of mix and match your terminology, but you find what affects you. And if you do that and you find an issue and it might apply to devices or assets you own, then you can look at things again from a different perspective. So acronym salad, I think this is a really important thing because when you hear about CVEs and CSS, there's a lot of words out there. It's an advisory, and it's a type of vulnerability disclosure that contains one or more CVE records. And each of those records will have a score, it'll have an identifier, and it will have a way to find it, right? There's a bit of a search string, if you will. But what does it all mean? And here's the four main components here. A CVE is a common vulnerabilities and exposure identifier. It's used to track and find the vulnerabilities. It shows who published it. It'll say, the date more or less and some sort of unique identifier. Nothing more really needs to be said about that. Then you have the score, and there's plenty to say about the CVSS score, a common vulnerability and scoring system. It's between 0 and 10, and we'll talk a bit more about that later, but it's just a metric, and it's supposed to describe the impact and criticality of flaws if flaws are exploited. Then you have the CWE, and it's a common weakness enumeration label, and it describes and classifies flaws at a high level. So it doesn't get into the nitty-gritty bits and the bytes. It talks more about a high level in a way that classifies it. Like, for example, what is a buffer overflow? You don't need to know that an array had 20 and you added a 21st element to it. It's just a label. And then you have the common platform enumeration, and you can't have a CV without a CP, and you can't have a CP without a CVE. So there's a very interesting piece here to consider, right? There's a chicken before the egg, but it's a vector. It's a way to find and map affected products to those CVEs, so then you can go do something about them. But tossing back, just to kind of give you a brief overview of the land, this is why you need to be concerned about this. So if you want to look at all these advisories, and surely there will be an information overload, you need to group them. And if I group them just with the 2020 ICS CERT vulnerabilities and kind of my own insights as a researcher, 58% of them are software and logic errors. And that kind of tells you something interesting. no product is secure and no product will be without bugs. So if you consider that and you take adequate steps, you're probably in a much better position. And then the other groups, right, access controls and sort of ACL logic. You have your information disclosures, hardware and system related, and system resources. And system resources are really a critical piece to take in mind here, because those are type of vulnerabilities that might really affect your process if they're exploited or even accidentally found by your teams. And then the graph on the right-hand side kind of demonstrates something else. So earlier I talked about there was, 70% of your assets are probably going to be on the embedded side. Well, the difference between the vulnerabilities coming out for embedded versus applications, let's say running on your Windows boxes, are roughly 50-50. And that was true almost in 2019. It was even more closer to true in 2020. But what that's saying is a lot of audiences and asset owners will focus on just the IT assets, the Windows boxes, the Cisco routers, the edge equipment, because they're more used to dealing with the vulnerabilities over there and reading the advisories and just accepting what the vendor is saying to them. But if you conversely take that, you'll have way more vulnerabilities on the embedded side and you're doing nothing about it. So should you do something about it? That's the reason why we're here today. So there's three main steps for reading advisories, and I kind of put in the joke there: read, find, print, find a robot, because generally there is robots in my presentations. But in this case, everything is really in the fine print when you read advisories. So if you take the rising tide of vulnerabilities between 2019 and 2020, you'll see that there was 248 ICS advisories, and I excluded on purpose the medical ones and a few of the transportation ones. But there was a 29% increase over the year previously. And if you take the vulnerabilities, 710 of those vulnerabilities, well, that was an increase of 47% over the year before. And there was also a 41% increase in scores that were over 8.0. But 2/3 of those alerts really involve issues that could cause unintended changes to the operation of your system, right? They could wind up with that device having irresponsive communication, not necessarily to exploit it and pop a box. It doesn't quite work that way at all in industrial control systems. You'd probably just break the box and shut down the process or cause an alarm to go off. But nonetheless, that's a situation you don't want because operators need to have visibility. So my first step would be to break it down. So I have on the left-hand side, we have an ICS alert from CISA. And it's got a score, right? So we can look at the basic information here. It's regarding an ABB power grid product. What we need to also consider is the overall risk evaluation. So they say successful exploitation of this vulnerability could allow for an attacker to remotely access the device without authentication. Well, that's probably true on many different realms, but it is the kind of the more purpose of it. We need to do something about it. Then we need to deal with what are the affected products, right? Does the vulnerability exist in it? Well, in this case, it's actually a third-party component. It's libSSH, which is a FOSS component, but it does say which products are affected in all versions. Great. I know that I can probably deal with that. We have our CWE, right? It says improper authentication, blah, 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 blah. It doesn't really mean much to most people, but it is network borne. But we can continue down that path. Our fourth step in this breaking it down would be, what are the mitigations? Well, there clearly is an update for these particular products and versions, so that's a great first step. So we'll go from that. We can do something. Our second step, though, would be to use labels. So if they would have had maybe more complicated CWEs, we could kind of use those buckets that I described in that pie chart earlier. If we take the example of buffer overflows or underflows, right? It's a software and logic problem. It's the way that it was written and it was not validated, didn't have guard code and so on like that. So we just put it into the bucket. It's a software error that could be bad. Okay, great. And depending on that flaw, a malicious party could potentially install their own code or hang the device, right? So that would be the consideration there, or even it could even be done accidentally. But we think in labels and associations, not at this thing, at that point in time, it does that. No, you need to think more of it in broader terms, and that way your audience would be more likely to understand it. And if you're a layperson, you're probably going to be like, what is the gist of this that I need to know? What is the bare minimum? And I propose to labels and associations. So again, in that case, you would have looked at the CWE, noted its region advisory, and you would have gone about the layperson's understanding. But here's 6 examples. What are labels really saying? So with those 6 advisories, We'll take the first one here, and there's a VxWorks vulnerability, and it actually affects a lot of products out there. Many industrial products use the VxWorks operating system by Wind River. And it says debug interfaces are left. What that means is the vendor didn't turn off all of the default stuff before they started piling on their own product to it. But what it's trying to tell you is that you need physical or network access to be able to exploit this set of vulnerabilities. If you don't have network access to that device, or even if there's no, for example, network interface card on it, you're probably off to a really good start. Should you be concerned, that's up to you and your risk management team. We'll talk about again more of that later. Then you look at these red line Entron switches, and you'll see there's a whole bunch of web-related vulnerabilities, a backdoor and insecure components. What that really means to you, don't put this on the internet. It's bad news bears. Then you have the Honeywell Control Logic, Control Edge, and PLC and RTU. Clear text transmission of sensitive secrets, or potential information disclosure, or all those similar types of CWEs. What that really means is you're probably, in this case, your password is exposed. Don't be talking to that asset directly over the internet, over insecure network segments. Have a VPN until you can get to a point where you're the only person you can trust within reasonable expectations, the network that it's on. And you don't mind so much if your password gets disclosed. Obviously you do, but you're just trying to control the risk here. Then you have on the bottom left-hand side the proprietary ICS protocol for the GE PAX, which is now an Emerson product, by the way. What this really means, and this is true for many of the control logics vulnerabilities out there for Rockwell, stuff for Modicons and Modbus, what this really is telling you is expect networking vulnerabilities and process impacts if they're touched in the wrong way, or potentially there could be buffer overflows inside of the implementations, or other sorts of vulnerabilities relating to the state machines inside those protocols. So protect them adequately, use deep packet inspection with enforcement, not passive tools. They don't actually reduce your risk. But nonetheless, that's what you try to take away from these things. And then you have the Mitsubishi Electric vulnerability. Here, this is resource consumption. These type of vulnerabilities really make me concerned, because these are the ones that will crash a device under certain specific conditions. So let's say, for example, your facility is largely steady state, and you've never had a problem, right? You have, let's say, 10 devices. There's 10 connections that are always connecting to them over some sort of data fetcher. And someone comes along and adds an extra connection. And some of these vulnerabilities are about if someone connects multiple times or disconnects, there's a finite amount of connections in a pool on those devices in their logic. And so let's, for example, if you had a pool of 10 connections and someone went and added an 11th connection, maybe it will stop any new connections from going, or it'll boot the first one off. So that's why I try to take those into considerations. Or you could wind up in a case where the device would reboot on its own because of a watchdog failure. But you really want to just understand the gist of this. This is a crash device under specific conditions, and I want to prevent that. Then you have another VxWorks vulnerability. I'm not picking on VxWorks here. There's a lot of great things about it, and all of the vendors seem to have these type of issues. But if you look at like the Urgent 11 and the Trek Stack vulnerabilities, they're about DHCP and a bunch of features that like IGMP that nobody will use in an industrial facility. We just don't use those things, and so they're not necessarily actually exploitable because they're not enabled. And but what these type of protocols and vulnerabilities are telling you is that there's a local application to them, not one that's born from random strangers on the internet. So if you're not using those features, you're much better off. So my step 3 would be to score and prioritize it. And yes, we already discussed they have a score, but what do I really need to ask myself, right? So basic CVSS scores are a guideline. They're a superficial metric. Often the risk actually could be much higher than the score, right? You might have a 10 vulnerability and that is critical, but it actually is more close. In other cases, it might be closer to a 6, right? A medium. In some cases, you might have a medium and it's very close to a critical because of your own interpretations of it as well. But really, you just use this as a guideline, and you're going to apply your organization's risk matrix and guidelines to modify these scores to ones that you need to consume, right? If I have assets that are really critical to me, I might pay more attention to those, and I might even multiply some of these scores because I know there's no compensating controls. So what you need to do is you take those scores and you ask yourself these type of questions. Is it applicable? Do I have effective assets? Right? Because automatically, if you don't have assets, it's a 0. It's going in the garbage. It's an NA, not applicable. What is the impact on those affected assets, right? If I have just one PLC that's affected and it's in the corner flipping on a light switch versus maybe another one that's actually controlling relays for turning off conveyor belts when someone presses a big red button, that's a very different level of scope. There's also different levels of risk exposure. How are those assets exposed? Are they behind various firewalls? Are those firewalls actually effective? Are there lots of persons going in and out and plugging in equipment that maybe could bring something into that environment? Are those controls that are protecting them effective? Do the risks here need treatment? So what that means is, do we need to mitigate them, right? Do these issues do they have to be managed? And if so, what needs to be done? And also you have the immediacy question. Do I need to deal with it now, next week, or the next deferred update or outage schedule, or do I need to never do it? But this all sounds really good and it all makes sense, but it's not always smooth sailing. So I'm going to talk about a few examples of the caveats of the system before we jump into the kind of the final steps of this presentation. So advisories, CVEs, portals, and OMI. So let's take this advisory from Flexera on ICS CERT. And if you're used to installing software on Windows, you've probably seen their products more than a handful of times, right? This is the things for install shield. When you go to install it and it's got all those wizards, this is what it is. And okay, you might say, okay, well, I'll read this alert and I'll try to see if it applies to me. So I look at it and it says Flexera, and I say, okay, it says it affects other vendors. Okay, I'm intrigued. I'll follow down this. And it says untrusted search path. If I'm an average person, I have no idea what that means. And to be honest, it really doesn't matter to you. You just know there's a problem. But okay, I'll bite. I don't know what it is, but I'll take your word for it. There's an issue. And then it says contact the product vendor support team. That doesn't help me at all. I don't know if I'm affected by anything. You're just burning my brain cells for no reason. But okay, I'm still going to follow down that path because in the CWE section of the ICS report, there's a CVE. So okay, I'll dive into it. So that takes me to the National Vulnerability Database. That's NVD. And it's got a score there. It's actually got a different score than the one that ICS CERT supposes for it. And we kind of dive in. Okay, so we got a CVS score. There's a vector string. Okay, well, that means nothing, but I'll continue down the path. I assume someone knows what it means. It's got those CPE matching strings. Okay, cool. It says Flexera. It says everything that it should say, except guess what? Your third-party vendors are not there. So that's another set of problems here that I don't know what to do with. But okay, we'll continue down that path. But if I went to a vendor's portal, you'll find out quickly each vendor has their own portal, and there's a ton of them. So good luck. They're not synchronized with each other. They should be. But the system is actually an honor-based system, not necessarily one that is legally and contractually required by vendors to deal with, and also government agencies. It's a best effort. Then you have cases where there's missing risk. So if you looked at ICS CERT, you'd see for the TREC vulnerabilities, it supposedly affects a bunch of vendors. And those CVEs do not actually match those vendors again. But let's take the TREC Ripple 20 vulnerabilities, and I'm using an older rendition of this Rockwell page. So it might have changed since I last looked at it, but I had a copy of it. So I came from 2020, and it talks about this branded vulnerability disclosure. Right? I say branded on purpose because it's been marketed as a product, something we should be afraid of. And we go through the report, and we see all the track stack CVEs, right? They match, and we see there's a whole matrix of different products that would be affected here. But we notice that only some of them apply. It's not everything, right? So you might say, oh, wow, no, it's mix and match. And even the scores for each of those would change. So we kind of look at it again and we see, some apply to others and some don't. And like I said, you don't see anything on NVD. So that no affected software configuration section is from NVD. It's a snapshot there. And I see nothing about Rockwell. I see nothing about power monitors. I see nothing about flex controllers for a different set of vulnerabilities. But there's a partial match. I can do the math and figure it out. But what do? I'm not an asset owner that writes my own rules to find the vulnerabilities. I'm not a product creator that maps all that together. I don't know what I am. I'm just the person who fixes stuff and makes sure that the lights stay on, right? So when you're managing these type of risks, there's all these caveats and holes, and you need to put all that together. Then there's the whole class of undisclosed vulnerabilities again. So we talked quickly about the TREC ones. At least the vendor was acknowledging it. But if you took the Triangle Microworks vulnerability that was at S4 that was disclosed in I believe the Pwn2Own contest, you'll find again in relation to my other GEUR vulnerability disclosures that we coordinated with CISA and GE on, you'll find that there's no mention of this unless you went into their portal, and there's nothing on ICS CERT for it. Zero, nothing. Not even on that vendor's page for the MicroWorks outstation libraries is there any mention of GE. So you would have had no hint to go find this. I found it by sheer accident. Then you have other things inside of build notes and release notes, right? The highlighted section there is from a Red Lion product. And it says it's a fixed bug that has a Modbus issue where if someone puts in something that is kind of what the developers weren't expecting, it would fail non-gracefully. It would lock up. Then you have from Rockwell an anomaly section for one of their ENBT cards, and it says don't set the static or the gateway address to 000, and you might have to deal with some changes, right? It might will accept an invalid gateway address, of course it will, but sometimes those things can be abused by persons like me if I want to disrupt your network, right? You'd have to go physically to each one of those units. Probably plug in a programming cable and undo what I've done. So at scale, I can use OEM functionality against you, and that is a risk that is not disclosed in the vulnerability system. So you could even make maybe a pseudo risk if you wish. So again, no mention on ICS cert. There's vendor design problems and user/logic errors. So acting on advisories. So again, we'll start with another good example here, right? We have a recent Rockwell Automation logic controllers alert. It just talks about there's hard-coded credentials in there and they're insufficiently protected. But there's a lot to unpack in this advisory because there's a lot of legalese. There's a lot of hiding what the real problems were. And I don't expect anyone to probably go through that effort, but you try to just look for the buzzwords, right? When you went to university or an equivalent institution, when you had lots of information, you scanned it for the relevant points. Advisories are largely the same in that regard. So we got the basic information. We got a score. It's something I should worry about. Great. Products noted. Fine. It's got something interesting. It involves software and the embedded product. So we need to think about two things here. Often, everyone only thinks about the embedded product or the application, but in this case, we need to also protect the application and the devices themselves. Okay, no problem though. We can do both, right? We're modern people. And we go dive into it. We got all of the right stuff on NVD. It's got matching CPEs. We're doing really well compared to other sets of vulnerabilities that I mentioned earlier. The problems, though, start to happen on the mitigations, though. Rockwell has determined this vulnerability cannot be mitigated with a patch, although it does suggest there's firmware updates. But what that's really trying to tell you is that most embedded products, even that is true for SolarWinds, a patch never can prove the integrity of the device, right? So if there's a way into it, or this is a fundamental problem in the way that, let's say, for example, someone does the verification of bootloader code, you can't actually update it unless you replace the product with one that doesn't have this issue, a newer rendition, or it's a whole new forklift change. So they're suggesting that you use a combination of factors, a defense in depth strategy to deal with those risks. But okay, you told me I really can't do something about it, but you are still suggesting stuff. It says that there's this on newer cards that support this common industrial protocol, or the secure SIP will help get rid of this because there's no hard-coded credentials for discovery, right? It's part of the TLS suite. But what that's telling you is that the real vulnerabilities are actually through the original SIP, actually. So that would be Ethernet IP, and that's not Ethernet in the layer 2 format. It's an industrial OBDA or ODBA type protocol, but in a previous life, you might have even known it with another name, which was called EPIC back in the early 1990s. So keep in mind, this is network born now. And if you had something that was doing enforcement of DPI, you actually might be able to stop this because not only can you block by ACLs, you could even get really down to the SIP classes and codes and block this in theory. There's other mitigations here that are mentioned. So, okay, protect it from, physical access, right? Turn it to run mode. Don't have the programming key set. Physically protect them. Don't have the key hanging off of the cage or the rack, hanging with a wire. They're also suggesting that you buy new products and use newer features if you can. That could be problematic for most of us that are cost conscious. But there is a reason and a process to this madness, and this was taken roughly from the 62443 guidelines. But this is how I would qualify, and even my colleagues would qualify advisories remediation. So on the left-hand side, we have more advisories. We assume that we've identified them and we found them, right? So does it affect us? Step one, what is at risk? What do we have? And how can we know if an issue or update exists, right? So we can manually look at these things. We can download definitions for our products and tools, but we need to know what's in our inventory and cross-reference that somehow. And hopefully that would be done through technology. Our next step is, do we have a workaround? Do we have compensating controls, right? So just because there's no fix, can we do a change, like disable a feature? Or do we have to rely on firewalls and just accept the risk, which isn't ideal, but largely that's what happens in the industrial space. Step 3, we need to analyze the risk, right? Can we quickly outline those vulnerabilities? That would be the step 1, break it down. Then what is the nature of that targeted flaw, right? That would be like a second step, the labels, the associations. Then ultimately, right, can we risk it? And so we would hopefully have a risk management framework that is defined by the organization and the organization goes by. That way, you're not creating the book and you're not accepting liability for yourself. But assuming that we need to do something about it, right? There's risks here that we need to be addressed. We can choose again to patch ASAP, right now. We can defer it with, to the next shutdown or the second shutdown, because maybe the first shutdown is, full of changes that have already been scheduled. And we also have the choice of doing nothing. But nonetheless, you're still going to always document and patch if you've managed your risks appropriately, right? And there's going to be work orders, and there's going to be, hopefully there's going to be some sort of documentation trail, audit trail, and you're going to have work orders that specify what you're going to do and the statement of procedure, the SOP to do so. But all of this has an impact on your cybersecurity management system. That's the 62443 term. Or if you're in other frameworks, your security program in general. So managing vulnerabilities and risks are really BAU, business as usual activities, right? But it will have an effect across your processes, your people, your technology, your risk management on the process side. How do you get that data into there, right? Like, and fetch it on a repeated basis. Is a person signed to it? Well, what do they have to do? It's tied to your asset management, and everything that you do, your change management really has to be cyber friendly. A lot of things are related to physical changes, right? They don't have a fast path for security necessarily, and there has to be, of course, playbooks for dealing with these type of things. Then you have the people, which is why we're here, right? We're trying to do some training. We're trying to get people, up to speed. This is just one way to do so. So you're going to have training for a disclosure review, and you're going to have training on the processes that you defined in the processes section. You're going to qualify your resources. Do they have the skill to make these assessments? And then you're, of course, going to assign responsibilities, because people need to be accountable for this. This isn't something you just willfully let go, right? That's negligent. You do need to be accountable for it, just like you would be the tires on your vehicle. If they're going bald and you get in an accident, you are responsible for making sure that they had enough tread to provide sufficient traction for the safety of yourself and for others around you. Then you have your technology, of course, right? And so that would be your automation, your asset management systems. You're going to have protection strategies and compensating controls, whether it's application whitelisting, that's backups. You're going to have methods to put patches into systems or so on. And then the reporting of all of that information all flowing up from the well, if you will. All of this and understanding vulnerabilities is critical to making these three pieces work properly, because what good is one without any of the others and with an overall understanding? Nobody's saying being an expert in understanding advisories, but what we're saying is that you need to have a certain level of awareness and being able to have a common vocabulary to discuss the problems at will. So my key takeaways are this. Have a plan and have a process. Any plan is better than no plan, especially if you go through testing it and you say, okay, new vulnerability comes out for, let's say we only have Rockwell products in our house, or Schneider. Well, we're going to subscribe to the relevant feeds. Someone's going to check up on it. Hopefully, maybe there's an email list. ICS Cert has one, but also maybe Rockwell has one too. Work with your vendor or your integrator, whatever it is. You need to have a way to get stuff into your business, get it in front of people's, keep in front on their screens, and you're going to have a plan to do something about it. Again, my other takeaway here is 100% knowledge is not required. Most of the time, you might see there's a lot of whizzes out there that can pick up stuff really quick, and they don't need to know necessarily how the electrons flow on a wire. They just need to know that they do. And so from a lot of my experience out there dealing with working with Special Olympics, with other persons that have disabilities, not saying that's a bad way to go about it, but in general, most society deals with a concept called rote learning. You know an apple is an apple because you've always been taught an apple is an apple. You don't need to know it's a flower and how it germinates and stuff like that. You just need to know certain things about it. And that's probably good enough in most cases. And so combined with some logic and critical thinking, that's generally quite sufficient. As I said, advisories and CV systems have holes. They are not the end all be all. and it's an honor-based system. So there's multiple silos of intelligence and data stores here. The scoring isn't perfect, but it is a metric and it is a starting point. So if you build on that and then add your own considerations with your security programs, you're in a very good place to make sound decisions that are not knee-jerk decisions. I would not want to ever do this on my own. I would not want to manually do this every day. It was enough to go through all of the 248 ICS advisories for 2020 manually and going through it and double checking all the data after I fetched it all. So you want to track all those vulnerabilities and disclosures with as few resources as possible, and you want the technology to supplement the human power, right? Technology is supposed to augment humans. Same with machine learning and AI. They say it's going to solve the world's problems. It probably won't. It needs to augment human beings to make the ultimate decision, especially industrial processes where safety is a thing. So if you do all this manually, this is a fool's errand. Yes, it might work for the initial, but it won't scale. Just like I have a finite amount of hours per day that I can work and read things. Change and risk management matter. Patching and understanding vulnerabilities is a change in risk management activity. Patching or any change in these environments or combination of results in change in risk management. So if an organization has this, you just need to make sure that reading advisories and doing things about it is just an extension of those principles. It's not net new. You wouldn't probably, for example, change the plumbing in your house if you didn't consider the process to go about making that change, getting a permit, getting a plumber, making sure that the water's off, right? You have to do these things and have a backup plan if all things go sideways. And lastly, my final takeaway would be it takes a community. No one knows everything about this. Even the advisories are not complete. There's discrepancies. There's actually politics in the way that you report vulnerabilities. Trust me, there's a lot in it. Very few people understand what goes into making things right. But there's always people available to really give you insights into how this stuff works and how to pull it all together. So I just want to make sure that everyone understands. Ask for help. There's always help available outside of your organization. So thank you for listening to this presentation. It's the second rendition of it. There is a full-out, hefty guide, the ultimate guide of reading ICS advisories on Verve's website. It's not a product pitch, I promise. It's just a more in-depth coverage of everything we just talked about here to cross-reference it. My email's there, my phone is there. Try not to spam me, but please go about finding this information. I'm happy to connect you to the right people as part of our community efforts. Thank you very much. And if you have any questions, please feel free to reach out. Thank you very much.